We have a new episode of the IoT Show for you, and this one is with Mike Hall from the Azure Sphere team. Mike, what do you have for us today?
I'm going to show you how to run ML applications on an Azure Sphere development board.
You never want to miss an IoT Show episode with Mike. It's today on the IoT Show. See ya. Hi everyone, you're watching the IoT Show. I'm Olivier, your host, and today we have Mike from the Azure Sphere team to tell us everything you need to know about running ML at the edge and in the cloud. Mike, how are you today?
Very good. How about yourself?
I'm fantastic. So it's morning here for me, but you are calling from UK, right?
Yes, that's correct.
You've been on the IoT Show a couple times. You've been in the embedded space for some time as well. But for those who don't know you, can you give us a little summary of who you are, what you're doing at Microsoft?
Sure. I'm Mike Hall. I'm a dev lead in Azure Sphere, specifically on the devices and demos team. You can probably see a few devices lurking in the background here.
Nice. One thing I love with what you're doing is like, not only are you developing the products and working with the teams on that, but you're actually telling developers how to use them. And I think our audience loved that a lot. So running ML at the edge and in the cloud. So first of all, let's discuss a little about why would you want to run machine learning on microcontrollers, devices that might not have been designed for this kind of things at the beginning, but we are seeing a trend of having to run this kind of intelligence down there and distributing that. So why actually? What kind of scenarios?
Okay, so I think it's worth starting off by just, we've mentioned ML at the edge. I think it's worth starting there and just describing what we mean by the edge. And so I think there's a spectrum here between microcontrollers that you also mentioned. So a good example of that would be something like an Azure Sphere development board. In this case, this is the seed development board, or a server. So the Azure Sphere development board is obviously at the smaller end of this, right at the edge where you'd typically run something that you might call TinyML. So for the purposes of this discussion, what we're talking about when we talk about edge is machine learning models running on the Azure Sphere device, right? But when we talk about edge in general, we could be talking about a physical server inside the workplace, or we could be talking about something further upstream in the cloud. So in this case, when we mention edge, we're talking about edge on TinyML running on Azure Sphere.
Got it. And so now we are seeing, as you were describing, that range of options for our customers to distribute that intelligence where they need it to be for, security reasons, for performance reasons, for data sovereignty, or privacy reasons. So we will actually look at a demo here. Can you start describing a bit about, what kind of scenarios we'll be looking at?
Sure. I think there are several examples of where you might use machine learning on the very edge, something like TinyML. One of the things you might be doing is looking at machine condition, monitoring a device, listening for sound or vibration on a device. Audio sensors could obviously be used to do those kind of things. You might be listening for certain conditions, the sound of something breaking, for example, or monitoring temperatures and these kind of things.
Yep.
In the computer vision space, there's lots of potential as well. You could use computer vision to read existing displays on legacy systems, for example. And as values change on that display that you're reading, then at that point you could upload data from there. I think there's many different types of scenarios where you could have machine learning on the very edge. One of the things you mentioned is performance as well. For certain types of devices, one of the devices I have here is Azure Sphere real-time robot, right? So this is hard real time. It stands up, it balances, it avoids obstacles that are in front of or behind it. So that's a real-time system. You want all the processing of that to happen locally, rather than streaming data up and having that analyzed in the cloud. But you can also do analysis in the cloud as well, right?
Yeah, some kind of a hybrid situation. Actually,
Yeah.
the thing, the demo you're going to show is definitely about that. And at the end of the day, data has a cost, and I think one of the main reasons I'm seeing customers asking for running machine learning at the edge is I don't want to send all the data to the cloud. Latency being one of the problems, but very often it's just a matter of like, hey, this thing is connected using cellular, costs me money. So I don't want to send every single stream. I just want to send things that are relevant for my end-to-end solution.
Right. Exactly.
So you have a little demo with a little scenario. By the way, just before we jump into that, just want to mention here publicly that I still didn't get my little balancing robot for my own demos, but just like, that put aside, let's discuss about, the architecture, the scenario that you're going to demo today.
All right. So I think one of the first things to mention is when we're talking about TinyML or machine learning models running on Azure Sphere, there are lots of examples already of machine learning models that are capable of running on Azure Sphere. So let me just switch over to my desktop for a second. So this is a slide that came from a recent IoT show that I think you're involved in as well, that shows a number of machine learning models that are capable of running on Azure Sphere. And in fact, for the demo we're going to be showing today, we're looking at the third one down, which is the MediaTek NeuroPilot Micro machine learning models. And specifically, we're going to be taking a look at person detection from that ML model running on Azure Sphere.
So Mike, let me just get some details here. So the reason why you're not doing everything on that board, you confirm, is that because that kind of hardware is not capable of implementing such rich algorithms as the ones that will allow to detect not just a person, but detect a specific face or a specific details there. You're able to say, hey, this is like you would do object detection at a high level. This is a person, but then you rely on a cloud system there to do the specific analytics on the data, right?
Yeah, I think for many applications, it's useful to combine that kind of edge machine learning model with a more powerful, more capable cloud machine learning model. In the case of the Edge ML, the piece that's running on the Azure Sphere board, in effect, that can be always on, always doing local processing. And as you mentioned earlier, it's not always talking to the cloud. And that could be useful from a cost perspective, from a privacy perspective. Obviously, the cloud ML model can be more powerful. It's easier to retrain and redeploy models based on the latest data. One example of where you might use this kind of Edge ML model would be something like a wake word. You may have some devices within your home that you want to ask about the weather, for example. And so those devices aren't always streaming data up to the cloud. What they're listening for is a particular wake word, in effect, that edge local machine learning model. And then when they hear it, they wake up and start streaming audio, right? So think of the similar situation here. For this demo, the wake word is the person detection, and then we connect to the cloud to send up images for analysis for person verification, if you will.
Yeah, that makes sense. And actually, with the description you made earlier on of the spectrum of options for running ML at the edge, in our case today, the edge being the microcontroller, but then you can also think of scenarios that instead of doing the real heavy machine learning in the cloud, you can use private cloud or Azure Stack Hub as an option locally on premises, which is a full-blown Azure that is running on the rack of servers. But in our case, actually, we have a little device and we have a connectivity to the web. We're doing that. So let's jump into the demo. Let's see how that works.
Sure. Okay, so what you should see at the top right of the screen is the display that I mentioned earlier. So this is display. It's connected to an Azure development board at the back. Hopefully you can see that through the wires. And then at the kind of bottom right of that image, you can see the RGCam camera. Obviously, this is a demo setup, hence all the wires, right? So what you can see on the screen, it's saying it's a person detect demo. Yes, you can see the camera, it's live. You can see my hand in front of the camera. It's saying that there's no person detected, right? So what I'm going to do is step away from the camera that I'm looking at you on and get in front of the camera on the Azure Sphere development board. And what we should see is that a person is detected, but the person isn't recognized, right? Because we haven't trained the cloud ML model. All right, so let's give that a try. So I get in front of the camera. and we get person detected and unrecognized. Okay, so that shows that the person detection ML model running on the M4 core on the Azure Sphere board is detecting the person, and then we're connecting to the cloud aspect of the ML model to verify the person, but there's nobody trained there. So let's get into the training part. What we've created is a simple web page. This is running on localhost, so it's not deployed out to the cloud. It's connected to one of the cameras, which is just down here. You can see me on it. So what we need to do is take a picture and then train the model and then step back in front of the camera. And at that point, it should detect the person and also recognize the person. All right, so here goes. I'll get in front of that camera. Take a photo, right? There's the photo, give it a name. Mike, hit submit. So this will send that photo and the name through our intermediate service up to the Azure Cognitive Services Face API to train a person into a person group that we've created. Right, so now that that's done, I should be able to get back in front of the camera. I should then be detected, and I should also be recognized. Let's give that a try. And there we have it, person detected, and it's Mike.
Nice.
Right.
Awesome.
So,
first take, demo working perfectly end to end with actual real training that you just did live of the cognitive services.
Exactly.
That's fantastic. So there's some obvious use cases here. Do you have some specific examples of where you would use that?
Yeah, I think there are several. I think there are lots of applications where the combination of local ML and cloud ML kind of work really well together. So for example, in the home environment, you could think of an appliance that could personalize to the family member that's using it, without doing any additional work, right? You just step in front of it and it automatically configures. In the industrial world, you could think about either monitoring devices or enforcing safety procedures for workers. I think there are a number of different scenarios that exist here.
Yeah, I can see that. And one of the things that that actually leads to my next question, which is a bit about the elephant in the room. One thing I like is that you didn't have to push to the device any personal information. There's nothing related to the actual mic. Like the data about mic is in the cloud. It's not on a device that potentially, well, even if it's Azure Sphere, it's something that's super secure. But you might not want to have data transition, on a public network, whatever, down to that device. So the question is, privacy and how do we at Microsoft approach this notion of implementing ML in context that sometimes could be borderline, right, in terms of people's privacy?
Right. So I think there's a couple of things that you touched on there, and I think there are two parts in effect to the answer. The first of which is, I think the question you're asking is, how does Azure Sphere help specifically in this kind of application? And I think the first thing is that from an Azure Sphere standpoint, Microsoft secures the device over its entire lifetime. And this is obviously really important for devices that are running ML applications, which involve sensors such as cameras or microphones, where privacy obviously matters. And so Azure Sphere provides a secure, unique identity for the device and a cert-based connection to cloud services. So no other device can pretend to be, your particular device. Again, this is important for ML applications because there's potential there for a malicious device to inject fake data that, if used in a training data set, would degrade the performance of all devices in the system.
Definitely.
I think another part there, I think, is that Azure Sphere has this notion of device update, right? So that gives you the ability to dynamically update the Edge ML model and push this out to your device along with any other software that you're running on the device.
I see. So the inherent security, actually some of the reasons why Azure Sphere has been designed were actually to be able to address this kind of scenarios at the edge on microcontrollers. So that's great. Then there's also a bunch of other aspects of responsible AI and so on that we at Microsoft are pushing to make sure that the implementation of these kind of scenarios are done responsibly, and preserving people's privacy and safety and security. Mike, developers will want to play around with that code. I hope that they'll be able to, and we have a link for our developers to follow up on that, and that's going to be aka.ms/IoT Show/ML on Azure Sphere. It should be appearing soon. There you go, down there. So aka.ms IoT Show ML on Azure Sphere to learn more about how you can use machine learning on Azure Sphere. And certainly some code from Mike to play around with. Mike, thanks a lot for joining us today. I hope to see you soon on the IoT Show. Don't forget to send me the robot as well. And for everyone on the show, thanks for joining today. Do not forget to subscribe, and see you soon. Mike.